Toothpaste production starts here, in mineral-rich quarries where limestone is extracted for its high-purity calcium carbonate.
Excavators remove carefully selected mineral blocks and transport them for initial crushing. This raw material forms the structure.
The crushed stone passes over vibrating screens that remove oversized fragments and impurities. Only finely graded particles.
High-speed mills grind the mineral into a smooth powder measured in microns. This controlled fineness guarantees a mild reveal.
Sorbitol and glycerin arrive as humectants that prevent toothpaste from drying out. Their smooth, syrup-like texture.
The humectants are transferred through sealed lines to prevent contamination. Precision valves regulate flow with exacting control.
Purified water forms the base of every toothpaste formula. Reverse osmosis removes minerals, while ultraviolet light eliminates. UV radiation sterilizes the water without altering its chemistry. This ensures
Agents. Powders are stored in sealed silos with controlled humidity to prevent clumping. Each silo feeds precisely into.
Screw feeders dispense exactly the required amount of each ingredient. Their accuracy ensures predictable paste texture and
The heart of toothpaste manufacturing lies in vacuum mixers engineered for pharmaceutical precision.
Water and humectants form the initial liquid phase of the toothpaste base. Their synergy controls moisture, flow, and long-term.
Thickening agents hydrate slowly to create body and viscosity. These polymers give toothpaste.
The abrasive powder is introduced under vacuum to prevent dust escape. It suspends evenly within the liquid base.
As particles spread, the mixture thickens into a smooth, opaque slurry. Even distribution prevents gritty texture. Surfactants like SLS create the familiar foaming sensation during brushing. Foam helps spread toothpaste throughout the mouth.
These microbubbles enhance cleaning coverage and help lift debris from tooth surfaces. Their presence shows proper activation of the surfactant.
Flavor oils, sodium fluoride, and mild sweeteners prepare separately before entering the main batch. Fluoride must be added with extreme accuracy, as dosage ensures enamel strengthening without excess. Technicians confirm measurements and quality parameters before additives enter the mixer. This checkpoint safeguards consumers.
Once all ingredients are inside, the mixer seals airtight to begin high shear blending. This encloses.
High shear blades distribute every particle evenly through the mixture. Thickening agents hydrate thoroughly, transforming the Vacuum systems remove trapped air from the paste to prevent foamy, unstable texture. Eliminating air pockets also improves shelf life and tube filling performance.
As pressure drops, microscopic bubbles escape upward, leaving the paste denser and more uniform. This controls. Flavor oils and sweeteners enter carefully measured streams to prevent overpowering the formulation. Their balance defines the classic Fluoride flows into the paste with exquisite accuracy.
As additives disperse, the aroma intensifies, and the paste transforms into its final composition.
To achieve absolute smoothness, the paste sometimes passes through a secondary homogenizer. This equipment.
As mixing completes, the paste cools slightly to stabilize viscosity. Precise temperature control prevents thinning.
Inline sensors measure resistance to flow with millisecond accuracy. This data helps operators adjust formulation. Small samples are drawn for rigorous laboratory evaluation. These tests verify texture, shine, color. Technicians spread the paste in thin layers to check for graininess. Uniform surfaces confirm proper abrasive displacement. H levels must fall with a narrow range to protect enamel and maintain flavor stability.
Fluoride levels are verified through ion analysis to ensure proper enamel strengthening capabilities. These sensitive tests provide.
Microbiological testing ensures the paste contains no harmful microorganisms. Sterile environments.
Once approved, the paste travels to holding tanks where it rests before filling. These vessels maintain controlled.
Gentle agitation keeps the paste uniform while preventing air incorporation. The paste becomes fully matured and stable. Quality specialists review all data, certifying that the paste meets every standard. Only then is the batch approved for tube production. Begins with high-grade plastic granules melted inside precision extruders. The material flows smoothly as it heats.
The molten resin emerges as long cylindrical sleeves, uniform in thickness and structure. Perfect wall thickness prevents
Tragas. Robotic cutters divide the sleeves into perfectly sized tubes. This ensures each piece fits standard caps and filling. Before filling, tubes pass through a multicolor printing system that applies branding, ingredients, and usage instructions.
Ink layers adhere to the tube surface through heat set or UV curing processes. Precise registration.
UV curing hardens the ink immediately, creating a scratch-resistant surface. This durability prevents damage during transit.
Caps are created through high-pressure injection molding, forming smooth threads and airtight seals. Proper shaping ensures
Robots place caps onto tubes, but do not tighten them fully yet. This positioning allows air to escape during filling.
Tubes travel upright along the filling line, where precision nozzles deliver exact paste amounts.
The nozzles descend deep into each tube to prevent splashing or trapped air. This downward fill technique ensures a smooth.
As the paste enters, it forms delicate spirals that pack tightly inside the tube. The paste's viscosity.
Sensors verify that each tube contained the correct volume. Even tiny deviations trigger automatic adjustments.
After filling, open tube ends move into heat sealing stations. Heat and pressure flatten and bond the plastic layers together.
Each tube receives a uniform crimp pattern that reinforces strength. The crisp folds ensure the seal stays intact during.
Cool air stabilizes the freshly sealed ends, preventing warping or distortion. Proper cooling is essential for long-term.
Caps are tightened to exact torque levels to ensure easy opening while preventing leakage. Consistency here ensures a premium user experience. Soft brushes remove any tiny residue left during filling. Clean surfaces enhance visual appeal and hygiene. This step prepares tubes for packaging.
Inspection tunnels analyze shape, cap alignment, crimp quality, and label accuracy. High-speed cameras catch even subtle imperfections.
Rejected tubes are diverted without touching other products, protecting hygiene and flow. Each rejected item is logged.
The tubes that pass inspection are now fully approved for consumer use. Their journey continues toward boxing and distribution.
Approved tubes move into cartoning lines where mechanical guides position them for precise packing. The system forms cartons around the tubes. Carton blanks open flawlessly to create sturdy boxes. Their dimensions match tube sizes with millimeter precision. Strong cartons defend against transport damage.
Robotic arms guide each tube into its carton without scuffing the print or deforming the crimp. This delicate handling ensures. Adhesive nozzles apply thin, controlled glue streaks to secure the carton edges. The glue sets rapidly under pressure.
Compression belts press the cartons gently, ensuring glue bonds uniformly across the surface. Proper pressure.
Labels containing product codes, destination data, and batch numbers are applied with absolute precision.
Tape sealers close each shipping box with reinforced adhesive. This tape withstands vibration, stacking weight, and humidity shifts. Proper sealing protects shipment integrity.
Pressure rollers guarantee the tape adheres uniformly along the seam. Secure sealing prevents accidental opening. This step prepares cartons for palletizing.
Robotic palletizers stack cartons in cross-layer patterns that strengthen the pallet structure. Their precision prevents
efforts. Corner protectors reinforce the load and absorb impacts during handling. These additions reduce damage to both cartons and
Stretch film binds the entire pallet securely, shielding it from dust, moisture, and vibration. The tightly wrapped layers make
Pallets enter climate-controlled warehouses where temperature and humidity protect the toothpaste's integrity.
RFID technology logs every pallet's exact location within the warehouse. This digital accuracy supports humans. When orders arrive, pallets are loaded onto outbound trucks, heading to wholesaler and retail stores. Load bars secure pallets tightly within the truck, preventing movement during transit. Proper stabilization reduces. At retail stores, workers unpack cartons and align boxes with labels facing outward. Clean presentation helps customers.
In the home, the toothpaste reflects an entire industrial journey, from minerals to machines to meticulous quality control.